Plaza. It is 625 meters with 6543 commercial vehicles per day. It was given by the survey. And then the site conditions are the CBR value is 5%. So we were having two options, either design with 5% or increase the CBR, but the code doesn't allow at 5%, so we have to take 8%. Then by this process, we have to increase the CBR. Then it is situated on the Yamuna bank, so we are having the granular material abundantly. That means we can use the GSB. Of course, it is not RBM. Many people confuse with RBM and GSB. RBM itself is not GSB. RBM becomes GSB when it is in the proper grade. So again, there are choices of GSB 150, 225, and 300 mm. We can go for this, but my younger colleagues will tell you that how it is varying. The things are changing when we are changing from 150 to 225 and 300 mm. The thickness of the slab is not varying. So this will be further explained by Dr. G.D. Ranjit Singh and then Mr. Suren Singh.
We have only five minutes left for your presentation. Can you do that within that? Please.
Practically, it would be really difficult, Chair.
I know it is difficult. I know it is difficult, but I have been put in this very tricky situation where I have to manage the time.
We would need at least 15 minutes, please.
15 minutes is not available, sorry.
Okay, anyway, we'll try our best.
Right. Maybe maximum 10 minutes, because you've already taken 10 minutes, I think.
Thank you so much. Yeah. Good afternoon, one and all. This is Dr. G.D. Ranjit Singh, RN, currently working as Associate Professor in the Department of Civil Engineering, IIT Roorkee. So I'm taking up the next slides. Thank you very much, Professor Praveen Kumar, for introducing the paper in a wonderful manner. Now, here, if we look at the design steps of the IRC 58-2015, it says that, yes, you assume the trial thickness of the pavement initially, and then you calculate the expected load repetition, and then go for the calculate the flexural stress for BUC, bottom-up cracking and top-down cracking. And we have to calculate the allowable repetitions. Then we have to find out the fatigue damage. The fatigue damage is expressed as the expected repetition divided by allowable repetition. Then we finally have to check the cumulative fatigue damage. Then if the cumulative fatigue damage is less than 1, then the trial thickness assumed is considered to be safe. So this is nothing new. It is already given in the IRC 58-2015. But here, the main journey starts here. As per the IRC 58-2015 subclause 5.7.3.6, doesn't allow the designer to have a PQC slab design for the subgrade CBR other than 8%. So initially we had to stick to the CBR 8%. Now at the same time, the client, as we were requested by the client to produce the cost-effective slab thickness, so we opine to use the granular material. At the same time, here let me be very honest enough that the client also told us that the gravelly materials in the vicinity of the construction site is abundantly available. They want to use that material. So how to produce the cost-effective slab thickness? That was the point. So in the endeavor of this process, what we have done is, why not to start with the subbase, granular subbase from 150 mm and try to get the PQC slab thickness. This we have done deliberately, despite of knowing the fact that as per the IRC 58-2015 subclause 5.7.4 says that you have to provide 150 mm DLC over the GSB layer. Okay, now our whole intention, the whole intention was to get the cost-effective slab thickness. Therefore, the granular subbase, to start with, the granular subbase of 150 mm thick we have done it, and the corresponding K value were read, and from the table number 2 of IRC 58, and we have tried to work out the cumulative fatigue damage for the bottom-up cracking and the top-down cracking after analyzing the axial load spectrum, and for the slab, different slab thickness like 280 mm, 290 mm, 300 and 310 mm respectively. Now, out of this exercise, what we found was 31 centimeter was found to be adequate for the prevalent or for the given traffic. And we were quite happy. And why not? To try the further, let us proceed with the design by increasing the granular subbase thickness to 225 mm from 150 mm. Having said that, the K value, effective K value would increase or would be higher for superior material and the stiffer material. So
5 minutes left, please.
under this perception, so the K value, effective K value was read, and then the design iteration was made again. But here we were disappointed. Despite of increasing the effective K value of the subbase, we were not able to reduce the slab thickness. We could not economize it. And similarly, we had tried for another thickness. Let us go for 300 mm. And subsequently, the corresponding K value, effective K value were read, and the design iteration was made again. Here, the thickness of PQC came out to be same. So, what to do next? So, in fact, here, what we have done is, this is only the story of the GSB layer. Now, why not to try with some other different types of subbase layer? That is a cement-treated subbase with the different thickness, 100 mm, 150, and 200 mm. Up to 200 mm we have tried for. Now, as we can see from this figure 1, that the thickness remained unaltered. Now, finally, we thought that let us try to club with the subgrade CBR and under this different combination, what would be the outcome? So after doing that design iteration also, we were disappointed. So the 31 centimeter, despite of increasing the K value, we were not able to reduce the slab thickness. So the remaining, the story would be told by Mr. Surender, my PhD scholar. Thank you very much.
2 minutes.
Sir, at least 4 minutes. Okay, without wasting any more time. So we decided to vary the third condition, that is the shoulder condition. So to look whether the slab thickness is reducing or not. Then by replacing the untied shoulder condition by tied shoulder condition, what we found that the slab thickness reduced by 4 to 5 centimeters. But at this input parameter to be constant, that tight concrete shoulder, the required thickness remained more or less same. And what we found that in cemented subbase, with the increase in the CBR, the slab thickness reduced. But again, with increase in the CBR of the subgrade from 4% to 5%, the required thickness of the slab again increased, which is totally opposite to a general perception that stronger subgrade and a stronger subbase requires a lesser pavement thickness to resist the flexural stresses than a weaker one. These are the regression equations which we use for the calculation of the fractional stresses as given by IRC-58-2015. Actually, there are different equations for bottom-up cracking and only one single equation for top-down cracking. We use these equations to calculate the flexural stresses and then compared with Portland Cement Association equivalent stress values and the previous guideline, that is IRC-58-2002. What we found that for a section of thickness from 4 inches to 9.5 inches, with the increase in the K value, the stresses value tends to increases. And for bottom-up cracking, and when the K value is more than 80, let's say 81, the stresses tends to reduce, and with further increase in the K value from 81 to 150, it again increases. And at 151, it again decreased, and with further increase in the subgrade or subbase strength, it again increased. And for the section from 9 inches to 14 inches, it was seen that with the increase in the K value, the stresses tends to increase. And for the top-down cracking, where there is only one single equation, with the increase in the K value for entire thicknesses, the stresses tends to reduce. Similar happened in case of the PCA, where increase in the K value, stresses tends to decrease. But in our case, if we use 58-2015 for the bottom-up cracking, with the increase in the K value, it can increase, the stresses can increase or decrease. So why it's not happening? Because we have to use the regression equations. If we use the regression equation when the K value is less than 80, let's say 1, and if we increase the K value from 1 to 80, the stresses will increase. And when the K value is just above 80, the user have to shift to another equation to calculate the stresses. Then the stresses value will reduce, and when the K values further increase below above 150, the stress value will again decrease. Then with further increase in K value, it again increases. But in case of top-down cracking, we have to use only one single equation. So with the increase in the K value, the stresses tends to decrease. So we casted this slab in the laboratory, and it was concluded there is an overestimation of the stresses in the IRC-58-2015. Then the comparison between 58-2015 and 2002, by putting delta T is equal to 0 in the equations, the equation will give the stress value due to the loading condition only. And in case of 58-2002, what we can see that with the increase in the K value, the stresses should reduce. But in case of our code, it was showing the same effect as by putting delta T is equal to some temperature differential of the area. Then one more interesting thing is that like we have to provide this slab size greater than 4.5 into 3.5. In some condition, we have to provide lesser dimension slab because of the land issues. So what we found that these guidelines, IRC-58-2015, are limited for 4.5 into 3.5 meter slab only. And we know that with the increase in the slab dimension,
please conclude.
Okay, with the increase in the slab dimension, the warping stresses increases. Then the graphical values and the equation value are giving different values. And then the conclusion that with the increase in the stiffness of the subbase from granular subbase to cement-treated subbase and the dry-lined concrete subbase, the required thickness of the slab remains same. Even for increase, if we increase this thickness of the subbase from 150 mm to 300 mm, or for cement-treated subbase 100 to 200 and dry-lined concrete 100 to 150, the required thickness remains the same. Also, with the increase in the subgrade strength from 2% to 10%, the required thickness still remained the same. The thickness only reduced when we replace the untied concrete shoulders from the tied concrete shoulders. And these equations are for 3.5 into 4.5 meter slab only. And these all I have already discussed. Then okay.
Thank you very much.